world, and it's 50% biochar. That's 6 feet of biochar. We don't have any on our land. We can produce biochar in our community and increase the char in our land and increase the health and fertility of our land. Now, let's also talk about what charcoal is good for. So, water is used to filter in charcoal. That's if you ever buy a Brita water filter, it's charcoal. They're using charcoal to filter water because it is a carbon product that is a negative electrons that attracts all heavy metals, all pathogens. It attracts viruses. It attracts particulates of any substance. Everything sticks to carbon, and carbon that's barren and empty, as biochar is available to stick to it. Anything can stick to it. So what I'm advocating for is not just making Brita filters for our drinking water, but making enough biochar out of our already existent overgrowth abundant vegetative mass that we already need to reduce and we need to burn before it burns us out from a wildfire out of control. Because this is fucking hot, and this isn't very much wood. It won't take long for our entire community to go up in smoke. So what we need to do is burn it without smoke. Do you see how clean this fire is? We are very low production of pollution right now. What we're creating is a release. It's a chemical reaction that happens at between 300 degrees and 800 degrees. At 320 degrees to 800 is when pyrolysis takes place. And the oxygen, if you look on the edges, you can see how the air is coming underneath the shield. It's rising up, and then because it's pre-warmed, as soon as it folds in, it's igniting and going straight up. And so what's happening is the heat is radiating within there and evaporating all the hydrogen and all the oxygen that's inside the cells. Every single cell on every single plant on everything is carbon. The cell is carbon. The contents of that cell are water and nutrients. That's what we're releasing. That's what the smoke you see that quickly becomes engulfed by flame. Those are nutrients. We are releasing nutrients, and we are releasing hydrogen and oxygen that can reform in our atmosphere and come back down as water. Now, if we wanted to capture that mineral and that nutrient in that water, you would need a closed kiln to be more effective, and that would be called wood vinegar. Wood vinegar is the distilled byproduct of all those gases that are being caught, and wood vinegar is a valuable product that you can look up and get access to. He's brought some. So wood vinegar is something that I am admitting we are losing because we are letting it go in the fire. Because I am not here to try to tell you that you have to do everything. I'm telling you everything that could be done. But what we can do that I'm asking you to do is start learning how to burn and turn it into biochar, to take what you understand, and if you don't understand, please don't leave until you do. The people to ask are Chari, Ken, me, or Tom. We're going to be able to answer anyone's question. And I want you to be able to leave here today fully confident that you understand what biochar is, how it's made, why we need it, and how to teach your friends and neighbors to do it too. And again, we're going to repeat this event so you can send people this way, and I'll be happy to lecture them for you. So the thing about getting the carbon in the ground is the cell of every plant is carbon, and the nutrients inside and water are inside each cell. When you heat it over 320 degrees, that water is boiling. Steam is escaping. The cell walls are breaking. The carbon is very loose. It's very fragile, and it's able to evaporate if oxygen were present. Which is why when you burn without the kiln, or without the knowledge of how to burn without a kiln, you end up having not that much ash,